Hi, hello. Good morning, one and all. Welcome to the session. Can anybody confirm about? Hi, hello. Good morning, one and all. Can anybody confirm? Just give me a second. All right. So, audio video seems to be दोनों clear है. ठीक है. Right. So in the last session, I think because of due to power issues, I was not able to take the RC circuits, source-free RC circuits. I thought of taking this session yesterday itself, but due to power issues, I did not able to finish this session. Okay, so now today I'll try to take up this two sessions, like one or two problems on source-free circuits, and then one or two problems on RC circuits. I'll take up so that you'll get better. All right. So if let us move this, let us move on to the session, right? So before moving on to the session, I just wanted to tell you some, small introduction about myself. My name is Naveen Kollapalli. Those who are very much new to the platform, this is a small introduction about myself. I have around 11 plus years of experience in teaching. Most of the times I'll be teaching electric circuits, machines, measurements, and power systems. Okay, I did my master's in power systems from JNTU Hyderabad. I cracked GATE and State Public Service Commission examinations too. And I taught more than 20,000 students since 2012. Okay, so quickly let us move on to the session, and do let me know about your presence. Can anybody confirm about audio and video? It seems to be fine, all good. Right. So if you want to solve this RC circuits or otherwise RL circuits, here capacitor is a element which does not accept sudden changes in voltage. Which does not accept sudden changes in voltage. So it will not allow sudden changes in voltages. Okay, so which means we are able to we can see like the moment when if you look at the DC source or DC source waveform, the waveform will be like this. But if you connect this kind of DC source waveform to the capacitor, you cannot observe the voltage across the capacitor like this. The voltage waveform across the capacitor cannot be like this, like a step signal, because it will not allow the sudden changes in voltage. Okay, so how it will be? Probably the voltage waveform is not going to become like a source voltage. To look like source waveform, it takes some time. That time we generally call it as transient duration or 5 time constants, and then later it looks like a source waveform. After 5 time constants, the voltage waveform, the voltage across a capacitor looks like the supply voltage, waveform. So here, the moment when you switch or the moment when you connect the capacitor with the source, it is not accepting the voltage immediately, and it is taking some time. So this time period we call it as transient period, and we are going to observe this period. We are going to observe the capacitor in this period. Okay, right. In one time constant, how much amount of voltage is going to be stored, or how much amount of voltage is going to be built up? In 2 time constant, how much voltage is going to build up? In 3 time constant, like at whatever the instant of time you want to find out, you can find out. Okay, so this voltage or this change in voltage from 0 to 5 time constant is generally given as Vc of t is generally given as, if it is a source free circuit, obviously it is not going to store, it is going to decay. That means what, initially it will be having some amount of voltage, and then later it won't lose the entire voltage to 0 within 0 time. So it takes some amount of time, that is again called as transient period or transient state. So it takes 5 time constants to lose its voltage or to lose its potential. So if you want to express this Vc of t graph in terms of this initial voltage and with respect to time, then we will write it as V naught into e power minus t by tau. Okay. Similarly, for this graph, this is for discharging capacitor. This is for discharging. That means what? In the network, if you do not have a source, if the capacitor is charged, now that capacitor is going to discharge. Okay. Now for charging case, it will be like Vc of t is equals to the steady state value and the initial value you will be having. So Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by tau. Same as like inductor currents only. Same as like inductor current variation only. Okay. So for RL circuits with sources, you will be having IL of t is equal to IL of t into IL of infinity plus IL of 0 minus IL of infinity into e power minus t by tau. In the same manner, you'll be having these kind of equations. Okay. So if you can remember, or if you can understand about these equations, then you can easily solve the networks containing RC elements without sources. With sources, you can do that. Okay. Right. So here, when it comes to the derivation point of view, we will be discussing the derivation point of view also. Like in some other classes, maybe other faculty might be taking. But in this session, I will be taking up the questions, how to solve the questions of RC circuits with sources and without sources. Okay. So please let me know your presence. Hi, Mangaraju. How are you? So if you can find out the network and the switching instance, then you can easily calculate the voltage or whatever the given parameters he is asking. Okay, the find IC VC for t greater than 0. Find IC VC for t greater than 0. Here, where is IC? IC is here. IC is here. Where is VC? VC is here. Alright. So he is expecting IC and VC for t greater than 0. T greater than 0 means what we are doing? At t equals to 0, we are opening the switch. We are disconnecting the source from the network. At t equals to 0, we are disconnecting the source from the network. That means from minus infinity to 0 minus. From minus infinity to 0 minus. The source is connected for a long time. It's a long time the source is connected. So if the source is connected for a long time, definitely this source is going to drive the current through this path and through this path, and no doubt the capacitor gets charged. No doubt the capacitor gets charged. Okay. So for a long time, if the source is connected, now t equals to 0 minus instant is called as steady state. In the steady state, capacitor behaves like an open circuit. Capacitor behaves like an open circuit. So if this is going to behave like an open circuit, no current flows. In the final, in the t tends to infinity, that means what? IC of infinity will be definitely 0. Now what is VC of infinity? VC of infinity in the open circuit, the voltage across 1 kilo ohm will be the VC of infinity. Voltage across 1 kilo ohm will be the VC of infinity. Can you tell me what is VC of infinity? If you want to find out VC of infinity, use voltage division rule, because this 50 volts voltage source will drive the current through the 600 ohms resistance and 1 kilo ohm resistance, and therefore you will get a voltage drop here. So VC of infinity is equals to VC of infinity means here VC of 0 minus, because it's a long time. No, from minus infinity to 0 minus is a long time. So if you can assume this is like a switching instant, 0 instant, and this will become infinity instant, right? Okay. So let me write here VC of 0 minus. This is also VC of 0 minus, and this is IC of 0 minus. Okay. So use voltage division rule and you can find out. Can you tell me how much is this 50 into 1 kilo ohm? That is 1000 divided by 1000 plus 600. It comes out as 500 by 16. 500 by 16 volts is the voltage which is going to be available across the capacitor. Alright, right. So now what I am doing, I am opening the switch at t equals to 0. I am opening the switch at t equals to 0. Now if I open the switch at t equals to 0, right, if I open the switch at t equals to 0, what is going to happen? This 600 ohms path and 50 volts element is going to be disconnected. Now how will be the network? Let's see. So this is how the network looks like. We will be having 1 kilo ohm resistor, and here we'll be having VC. VC is taken as like this because the polarity across the capacitor will be same as the polarities of 1 kilo ohm resistor. So VC, how much we have got? 500 by 16 volts. And you can have capacitor. If you want to represent, you can represent capacitor also, or else you can simply represent a short circuit. Just after opening the switch, how the capacitor behaves? The capacitor behaves like a short circuit just after switching. Okay, and this side, what is the amount of resistor? 400 ohms. Now here we have a 600 ohm resistor, we have a 50 volts voltage source like this. Okay. Now there is no source, there is no source current here because it's an open circuit. Alright, it's a switch is open circuited. Switch is open circuited, so no current flow. Right. Now the capacitor is the only element which has energy in it, and therefore the capacitor is going to discharge through 1 kilo ohm resistor and 400 ohm resistor. Yes or no? Now the current direction is not actually top to bottom, it is actually bottom to top. So the current is circulating in this direction while it is discharging. Right. So you can calculate now Vc of t, how the voltage across the capacitor is going to decay. It is going to discharging now. So this capacitor is going to discharge in the absence of source. In the absence of source, capacitor is going to discharge. So how it is going to discharge? V0 into e power minus t by tau. So this is what the voltage expression across the capacitor for t greater than 0. After opening the switch, how the voltage across the capacitor is changing. So this equation will give you. Can you tell me how much it is? 500 by 16 into e power minus t by tau. Can you tell me how much is tau? How much is tau? You have to see from the capacitor through which path it is discharging. So this is 1 kilo ohm and this is 400 ohms. So the R equivalent will be 1400. R into C. So R will be 1400. C will be, C is how much? Can anybody tell me how much is C? 2 microfarad. बताइए ये कितना आएगा? 14 गुना 2 28 10 to the power of minus 6 and 10 to the power of 2, 10 to the power of minus 4. So probably 2.8 milliseconds. Right. So tau you can replace 500 by 16 into e power minus t by 2.8 milliseconds. This is the voltage expression we are going to get. Huzaifa, there are like if you are from electrical background, please let me know which branch you are from. Are you from electrical or EC or instrumentation, so that I can tell you. Let us have a look at this question. Huzaifa, can you respond? Which branch? Are you from electrical or EC? If you are from electrical or EC, like there are common subjects, right? So the common subjects, this will be for everyone, maths and aptitude. Don't leave this. 28 marks. Don't leave this. If you prepare this, definitely you can clear your gate. And if you belongs to electrical or EC, definitely networks, control systems, signals and systems, and analog. These 4 subjects will give you around 30 marks at least. So prepare these at least 4 to 5 subjects are including mathematics and aptitude, and along with that networks and controls, signals and systems, analog. So I'm damn sure it will give you a good rank. 58 marks is not a small amount, right? I'm just giving a rough number here, 30 marks. It can be more than 30 marks also sometimes. So if you can score 100%, that's a good thing. If you are not able to score 100%, maybe out of 58, if you are able to score 55 or 50, that's a good thing. So that will keep you a better rank at least. That will keep you better rank. May not be all India, it may not come under 50, AR 50, but it will be a good ranking maybe in 2000 or 2500 like that. Okay. Right. So look at this question, find Vc and V and I for t greater than 0. If Vc is equals to 50 volts, if Vc is equals to 50 volts, Vc of 0 is equal to 50 volts means initial voltage across a capacitor he has given. Initial voltage across a capacitor he has given. That means what? The capacitor is already charged and connected to the network. Now the capacitor is going to discharge the amount of the energy which is stored in it. Okay. So while it is discharging, he is asking to calculate Vc, V and I. So where is Vc? Vc is here. Where is V? V is here and I is here. Anyhow, we know Vc of t is equals to V naught into e power minus t by tau. V naught into e power minus t by tau. What is V naught? 50. What is e power minus t by tau? Tau value. Can you look into the tau value? Tau is equal to R into C. R value I need to calculate. C value is 1 by 2 farad. Can you tell me what is R equivalent? 6 and 12 are in parallel. 6 and 12 are in parallel. So the capacitor is discharging its energy through 8 ohms and 12 ohms and the 6 ohms also. Alright. 6 and 12 are in parallel. So 12 6 is 72 plus 18. No, sorry, 72 divided by 18. 72 divided by 18 plus 8. So this is my R equivalent. Okay. Can you tell me how much is this? (72) divided by 18 plus 8. 12 and capacitor is of 1 by 2. So we will be getting 6 seconds. You're welcome, Mangaraju. Okay. So 6 seconds. So 50 by 50 into e power minus t by 6. So this is the voltage across a capacitor for t greater than 0. And then later he is asking V, voltage across this resistor. How do you get voltage across this resistor? Use voltage division rule or current division rule. Find current division. If you can find out the capacitor current while discharging, then you can use current division rule. After finding current division rule, multiply with resistance, you will get it. What is IC of t? IC of t for t greater than 0 is equals to C into dVc by dt. So if you differentiate the voltage expression, 1 by 2 into differentiation of this 50 into e power minus t by 6, that will be 50 into e power 50 into minus 1 by 6 into e power minus t by 6. Okay, so this comes out to be minus 50 by 12. Minus 50 by 12 is going to be around 4.16. Minus 4.16 into e power minus t by 6 amperes. So this is the capacitor current. He has given the current in opposite direction. So I can say that capacitor current is quite opposite to I. Okay. So this will be equal to minus I can write. So that's the current equation. And once you find the current equation, use current division rule. Use current division rule. Use current division rule. If you use current division rule, then you can find out the current flowing through 12 ohms. Current division rule, you can find out the current flowing through 12 ohms. So multiply with 12, you will get the voltage. Okay. So that's how you can calculate. Right? Now coming to RC circuits with sources. RC circuits with sources. If you see, until unless if you look at switching instant, you cannot find whether the source is connected or not. Right? You see the switching instant. You see the switching instant. The switch is closed at t equals to 0. That means what? Minus infinity to 0 minus, it is not closed. Minus infinity to 0 minus, that is not closed. Okay, that is open. Open means if the switch is open means this voltage source is connected to capacitor and the capacitor is going to store the amount of energy, right? So by the way this voltage source is given as 20 into e power u 20 into u of minus t. U of t signal will be generally like this, na? This is u of t signal. Okay, if it is u of minus t, this is positive time and this is negative time. So u of minus t will be like this. This is u of plus t and u of minus t will be like this. So I have u of minus t. So I can take up like this with a magnitude of 20. Chalo, let us take up this magnitude as 20. Okay, that means what? U of minus t signal is existed from minus infinity to 0. Greater than 0, that value will be that source value will be 0. Okay, so 20 u of t, sorry, 20 u of minus t value will be 1 for t less than 0 and for t greater than minus infinity and less than 0. T greater than minus infinity and less than 0. And this u of, not only this 20 u of t also, u of t signal, u of t value will be 1 for t greater than 0. Okay, so here I have got u of minus t. Definitely u of minus t will be what? Once after the 0, u of minus t is not existed, so it will be 0, I can say. Okay, so the moment when you connect the switch, just after switching instant, anyhow this source is becoming 0, right? Now this 3 amperes current source will be connected with respect to the network. Okay, so let us see one by one. First, calculate initial voltage. If you calculate initial voltage, Vc of 0 minus will be for a long time from minus infinity to 0 minus, the u of minus t waveform is connected. If u of minus t waveform is connected, definitely this voltage, the voltage across the capacitor is going to be definitely stores full amount of energy. So how much is that? Vc of 0 minus is going to be, no doubt it will be 20 volts. Because if it is an open circuit, no current flows through the 5 ohm resistor and no drop across the 5 ohm resistor. Whatever the source voltage is there, that amount of source voltage is available across the capacitor. Alright. Now, if you close the switch, so capacitor initial voltage 20, I can write it as Vc of 0 minus and Vc of 0 plus, both instant it will be same. Now, at t equal to 0 plus instant, the capacitor acts like a short circuit. And this is, I am closing the switch at t equals to 0 instant, 10 and 3 amperes. This is 10 ohm and 3 amperes current source. Okay, right. What is asking now? Is asking I of t, V of t for all time. If he is asking for all time, means for t less than 0 you can calculate. For t less than 0 you can also calculate. Okay, so at minus infinity, did you minus infinity, we, let us assume we did not connect the 20 u of minus t, and if you are going to connect at minus infinity, okay, just after connecting the source, the voltage across the capacitor will not become 20, right? So initially it will be 0. So for t less than 0, the voltage expression will be, final value is 20, initial value is 0. So 20 into 20 plus 0 minus 20 into e power minus t by tau. What is the tau? As it is charging, the charging time constant is resistor into capacitor. So resistor value is 5, capacitor value is 0.2. So it is just 1 second. So this is the voltage expression for t less than 0. Okay. Similarly, differentiate this, you will get IC for t less than 0. And now for t greater than 0, this is how the network looks like. Initial value is 20, and now final value, how much you will get? For t, at t equals to 0 plus, this is how it looks like. At t equals to infinity, how it looks like? Again, the capacitor behaves like an open circuit, 10 ohms, and here 3 amperes. So this 3 amperes current source is going to drive the current through 10 ohms only. Yes or no? So if 3 amperes current source is going to drive the current through 10 ohms, then you will get a voltage of 30 volts. So the final value is Vc of infinity is 30. Now for t greater than 0, if you take up Vc of t, final value is 30, initial value is 20 minus 30 into e power minus t by tau. What is tau? You have to see from this capacitor, from the capacitor. So if you see from the capacitor, so 10 ohms, R equivalent will be 10 ohms. C equivalent anyhow we have got it as 0.2 or 0.2. So tau will be 10 into 0.2. You will get it as 2. You will get it as 2 volts. Similarly, again, if you differentiate this voltage expression, 0.2 into E, 0.2 into dVc by dt, if you do the differentiation, then you will get current expression. Okay. So these are some questions based on RC circuits with sources and without sources. Like these are some some promotional kind of things. How we take up the sessions and on the BYJU'S exam platform. So on our paid batches, we are going to discuss much more in detail, right from the derivation part to solution part. We'll be taking in details on the paid courses. Okay, so try to enroll with us so that you'll get benefited and you can crack the examination too. All right. Okay then. Thank you so much. Have a nice day. Bye bye. If you have any doubts, you can ask me, or else you can write a mail to my mail ID also, naveen.vellapalli at byju's.com. Okay, chalo. Thank you so much. Have a nice day.